Hello, am I audible?
Yes, sir.
Okay. Okay. So, hello everyone. My name is Lohit Koyal. I am from IIT Bombay, and I will take weekly live session on this course, Scientific Computing using Matlab. So today, first let me share my screen. So, can you see the screen?
Yes, sir.
Yes, sir.
Okay. Thank you. So, so today what I have total 20 problems. Okay. So first 10 problems will be MCQ problem, and the rest of the 10 are some numerical problems which you can do very easily. So here the first week deals with some basic things in MATLAB, like using plot, how to write a function, how to use symbolic computation, and etc. So let's start with it. So first let me tell you. So here all these things. Just a second. Right. So here all these things, these are text. Okay, and in the inside the gray shade, this is code. So I have done using MATLAB. So this is an interactive toolbox of MATLAB. So I am using that. So first, so let's start. So it is already 7. So let's start with it. So the first question, the first 10 questions, as I have told, the first 10 questions will be the MCQ questions. So oh, sorry. Let me just do one thing. 1 second. Huh? Yeah, now it will be much more easier. Okay, so let's start with the first question. Pick up on that. So the first question is, which of the following statement is incorrect in MATLAB? Okay. The first one is MATLAB is case insensitive. That means suppose you are giving two variables to MATLAB. Okay. Suppose one variable is A and another variable is capital A. Okay. So the option says that for MATLAB, this small a and this capital A will be the same. Okay. The second option says the command SYMST declares T as a symbolic variable. We all know that this is right. As you have done in the last week, this is how we define a symbolic variable, SYMST. Now everything in MATLAB is a matrix. Now the full form of MATLAB is matrix laboratory. So obviously everything in MATLAB will be in term of matrix. Okay. So whenever I define something as suppose you have probably done something in the last course as 0:2:6. Okay. So it will give you a row vector. Okay. So it will be like 0, then 2, then 4, then 6. So this is a row vector and which is a 1 cross 4 matrix. Okay, so everything in MATLAB works like a matrix. So this option is true, and MATLAB does both symbolic and numerical calculation. This is quite obvious. Numerical calculation is fine. we mostly do the numerical calculation, but also whenever we want to do symbolic computation, we can always define the like SYMST. So this option is also true. Then again we go to this first option, that MATLAB is insensitive. So obviously this option is not, so this is not true for MATLAB. Okay, so here I have given two examples. So one is small a equal to pi and another a capital A equal to 27. So when I am giving an input 5a, it is giving the 5 times pi, which is 15.7. Okay, and whenever I am giving 5 into capital A, it is giving me 135. Okay, so this means MATLAB treat these two variables. This is a lowercase, this is a uppercase. So MATLAB is treating these two variables as two different. So option A is the correct option. So which one is the incorrect? That MATLAB is case insensitive. This option will be incorrect. Okay. Now let's. So when if you have any doubt anywhere, you can stop me and you can ask me questions. Okay. Now let's go to the second problem. So what will be the input output of the following code in MATLAB? Okay, so suppose A is P equal to, just being, this is not correct, so P equal to 1 5. So okay, so the code option is P equal to 1 2 3 2 9. Okay, then my first input will be 1. Colon 3 means there will be gap of 3 there will be gap of 3. That means 1, then the second one will be 4, and the last one will be 7. All right, here the first option says 1 then 5 then 9. Can you, when this one will be true, if I give the code like this, 1 2 4 2 9, then this option will be true. Then the initial entry is 5, then a step of 4, that means the next entry will be 5, and the last entry is 5 plus 4, which will be 9. Okay, this option, so this is the correct option. This is obviously not true. It just write 1 3 and 9. It is not this is not a valid option, this option, and none of this also not not true. So here this is the code. If you have open your MATLAB, just type this P equal to 1 colon 3 colon n. That means 1 2 9 with a, yeah. Shoham, do you have any questions?
Said the access from our SWAM app for NPTEL MATLAB, we are unable to access that one.
Okay,
It,
so you
it
are
is showing that expired on some
uh,
2022.
you contact with the NPTEL team. I think they will help you out in that case. Huh? You contact with the NPTEL team, they will help you out.
Okay, sir.
Just write a mail or to them, or if any other communications in the portal, just do that. They will help you. Hmm. So in common language, what does it mean? That means 1 to 9 with a step of 3. Okay, so the syntax is 1 colon 3 colon 9. If you write 1 to 9, then by default MATLAB will assume that the step is 1. Then it will just write 1 2 3 4 dot 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 up to 9. Okay, so this is the correct choice. 1 colon 3 colon 9. The answer will be 147. Okay. Uh, yeah, someone has a
Uh,
question.
sir,
Shahu. Huh.
sir, actually, I'm not getting how 147 be written.
Okay. Let me repeat that again. Okay. So just let me erase this first. Yeah. So 1 colon 3 colon 9. Okay. First, just understanding common language. Okay. This is for MATLAB, but for us it will go from 1 to 9. Okay. If you just write 1 colon 9, it means that it will go from 1 to 9. Okay, and the result will be 1 2 3 4 5 6 7 8 9. Okay, I just tell me, have you understood this thing, 1 to 9, how we are getting this thing?
Yes, sir. Yes, sir.
Okay.
One.
Now, whenever you put a 3 inside, okay, or some other thing, 2 maybe, 4 maybe, 6 maybe, anything, okay, it will tell you go from 1 to 9, but with a step of 3. Okay. Then the first entry, then the first entry will be 1 as usual. Then, but the second entry will be 4 because it is at step 3, 1 to 4, 1, 2, 3, step 3. Again, from 4 there will be step 3. This, there are three elements, three step. So this is how you are getting this thing. Okay. So first one is 1, then the gap will be 3. You just add with the initial one. 1 plus 3 is 4. Again, 4 plus 3 is 7. This 3 indicates that there will be intermediate step. Okay, the step size is 3. So this is how MATLAB works. Okay, now I think is this clear. Now
Yes,
let's
sir.
okay, thanks. Now let's go to the next question. Now consider, okay, so we have to, so now how to write. So first of all, how I will give you a brief recap about how to write a matrix in MATLAB. Okay, so any matrix, suppose I want to write, suppose just don't consider this question right now. Suppose I want to, this is a matrix, we all know. Okay, it has 2 rows and 2 columns. Okay, so now how to write it in MATLAB? We can write in MATLAB in this way: 1, comma 2, colon 3, comma 4. Now what does it mean? Whenever you see a comma, okay, it means that it is a column separation. That means what? So suppose this element, this is at the first column, this is at the second column. Okay, and I am writing it in terms of 1, comma 2. Okay, whenever there is a comma, there will be separation in column. This is the it will be in the first column, it will be in the second column. Okay, now when I am writing a semicolon means it will be a new row. Then the next element will start from a new row. So you see the first row stops at 2. Okay, then it is going to the second row, the new row. The new row I am going to the new row using this comment, this syntax: colon, semicolon. Then again the first element will be 3. Again, comma means what? Comma means column separation. That means it will be in the same row but in a new column. So then I am going to column 4. Okay, let me give you another example. Suppose a matrix B is 1, -1, 0, 2. Okay, now what will be, now if I follow the same thing, what will be the case? B equal to 1, comma -1, because comma indicates a column separation. Colon means a new row will appear. 0, again comma 2. Okay, so if you want to translate from here to there, 1, comma -1, 1, comma -1 is the first element is 1, then a comma, that means the new column will, the next element will appear at the next column, that is -1. Colon, that means it will appear in the next row. The first element is 0, and the second element, it is a column separation. That means it will go to a next column, it will be 2, and you will get this result. Just practice this in MATLAB. Okay, then you will understand it very easily. Just write this kind of thing. Suppose a equal to something like 5, 3, 0, 7, something, anything you write. It may be 2 cos 2, 2 cos 3, anything. Okay, sorry. Okay, so now let go to the question. Let me just erase this thing. Now, okay, now this is a good exercise. Now I have -2, 0, then colon 0, 2, then colon 0, 1. Okay, then what will be the matrix? A equal to, see, the first element will be -2, then comma means it will be a new column. so 0. Then colon means a new row, element will be 0. Then again comma means a new column, 2. Then again colon, a new row, 0, and a comma, that means a new column, 1. So this is a 3 cos 2 matrix, right? So I hope you have understood how to translate from here, how I am going from here to here. Okay, now this comment size. So if you just write size of A, now it has 3 rows, 2 columns. If you just write size of A, it will give you 3 space 2. Yeah, here I have written that size of A is 3 space 2. That means it has, we already know that it has 3 rows. So the 3, this indicates 3 rows and 2 columns. So it is 2 columns. Okay. Okay. The question is, which MATLAB command will lead to some error? So obviously I have written in the code, this is the occurring no error, because this is the inbuilt command in MATLAB. Okay. Whenever you give size of A, it will give you the number of rows and the number of columns. Okay. Okay. Now I will come to these two, but first deal with this date of A. Date of A, determinant. That means determinant of A. Now we all know that in MATLAB the determinant in mathematics the determinant only occurs for the square matrix. For any rectangular matrix of this kind, m cross n, with 3 cross 2 matrix or 5 cross 4 or 1 cross 2 matrix, you cannot find a determinant in there. Determinant will only work on for the square matrix. If you write this in MATLAB, it will show you a error. Okay, so that means this is not consistent with MATLAB. We cannot find a determinant for this matrix. Okay, so obviously this option is the correct option, but most importantly, let's go to B and C. Okay, I hope you have understood so far. So I am erasing this part. Now A comma A. Okay, so whenever I have a matrix, something like this, so what I have told, that a comma indicates that the new element will appear at the next column. Okay, but here there is a comma, but here A is a whole matrix. Okay, A is this matrix. So how to interpret this? So first let me write what minus 2, 0, 0, 2, and 0, 1. Okay, now in this case, to understand, okay, just consider A as a whole element. Okay, and the next element will appear at the next column. So just let me write it. So this option A comma A, when you write it in MATLAB, you will see something like this: minus 2, 0, 0, 2, 0, 1. Treat this thing as a whole element. Okay, just like this case. Just treat this just like this case. Okay, here you have treated minus 2 as an element. Here treat this whole thing as an element. Okay, and the new element will appear on the next column. Okay, that means how will it look like? It will be again minus 2, 0, 0, 2, 0, 1. Okay, that means what? Treat this as a whole element, and the new element, which is again matrix A, it will appear on the next column, and this treat as a column. Okay, so this is called catenation process. Okay, so if you just try it in MATLAB, I have already shown here. This is A comma A, and you will get this result: minus 2, 0, 0, 2, 0, 1. This was I have told that treat this as an element, and the next element, as it is comma separated, will appear at the next column. It will be again minus 2, 0, 0, 2, 0, 1. Okay, this is not the correct definition, but this is just help you to understand just the intuition that a comma means that it will be column separation. Okay, again exactly the same thing. What will be a colon? A colon means what I have told for any matrix, that a colon means either new element will appear at a new row. Okay, So here, what will be the case? Here it will be A colon A, then the A colon A, it will be, so my original matrix was this minus 2 0 0 2 0 1. Okay, and the next element, appear at the new next row, so you have to treat this as as a whole element, and and it will be again minus 2 0 0 2 0 1. So I am treating this whole is A as a whole element, and the new element is appearing at a new row. Okay, so this is how to understand this kind of comment. So this is also, these two are known as the catenation process, where I am combining two matrices. So you can do, yeah, and this is the MATLAB code for that. So minus 2 0 0 2 0 1. This was I have told that treat this as a whole element, and this will be the new element. Okay. Now suppose you can do some exercise of your own. Just just you can think it and tell me. Suppose you have a matrix something like 1 2 3 4, and a matrix B which is equal to uh, 1 0 minus 1 2. You can tell me what will be this matrix A comma 2B and A colon B. The same thing will happen here. For it is multiplied by 2, you can multiply with anything, anything will work. Just you can just tell me, take 2-3 minutes and tell me, and then I will show you what will be the results. Okay, and now if you don't have access to MATLAB right now, just write it to NPTEL. They will provide you the access, and you can try it then in the MATLAB in code. Okay, it will exactly look like same. Just take 2-3 minutes and try it. Let me. Yeah, someone raised a hand. Yeah.
Bro, I actually I'm not being given the access. I already
So yeah, so write it to NPTEL. So I don't know. I mean, what actually I don't actually have contact with them. So
okay.
you write it. I will send them a mail that you don't have access to it. So I will send them a mail. Obviously. Hmm.
I actually sent a mail in that discussion forum also.
Okay. I will mail them. Sure, I will mail them.
Okay, bro. Thank you.
Sir, first one gives 2 cross 4 matrix.
First one give 2 cross 4 matrix. Can you tell me what? Just a second. Huh? Just a second. Let me start recording again. Yeah. Huh. So can you tell me what is the first matrix? Okay, just let me write it. Uh, somebody raised a hand. Pramanik. Yes.
Yes, sir. I would like to ask one question.
Hmm.
Sir, when I put z equals to a comma 2b, it is giving error and saying that you have to check the multiplication operator. So just a comma 2b means 2 star b, or
Okay, 2 star B, 2 star B. Yes. Sorry. 2 star B. Yeah.
okay,
Two
sir.
star B. 2 star B. Yeah.
Okay, sir. So the first answer a comma 2 star b will give us 1 2 2 0 3 4 minus 2 and 4
Yeah. So 1 2 2 0 3 4 minus 2 4.
and 4.
Right.
And the
Right.
second one a comma b will give us 1 2 1 0 and 3 4 minus 1 and 2.
Right. 1 2 3 4 1 0 minus 1 2. You have got this answer, right? 1 2 3 4 1 0 minus 1 2. Ah, yeah. Okay. Yeah. So yeah, so I will write a mail to NPTEL telling you that many of you don't have any access to MATLAB. Okay. So I will share this document with you. I mean the fresh document, not with the RAF. So you can always use it, and I think it will help you when you get the access. Okay. So let's move to the next question. Yeah. So this is another thing in matrix. So suppose you have, so okay, so as now we have learned how to interpret this command. So now the matrix will be 3 1 minus 1 2. Okay, now how to find each element of this matrix? Okay, so now if I have a matrix like this, A equal to A1 1, so this is from our school level mathematics. This is first row first column, this is first row second column, this is second row first column, this is second row second column, A11 A12 A21 A22. Now in MATLAB you cannot write it like this. Okay, this subscript thing don't work there. You have to, in terms of MATLAB, it will look like this: A1 comma 1. That A1 comma 1 means first row first column. So there will be obviously no bracket there. Okay, so I'm just writing it for the consistency. The next thing will be A1 comma 2. You have to interpret as this is the first row, the first element inside the bracket will be row. Let me just write it. So this is a row and this is column. This is column. Okay, so this is not clear. So COL means column. This element will be A21. That means it is the second row and first column, and this is A22, second row, second column. Now the question is, what will be the output of the command A12? And obviously the A12 means first row, second column. So that means first row, second column, that means this one. So this one will be the answer, A12. Okay, I think this is clear. Okay, so now more new command will come right now. So which command will give you the inverse of a square matrix X in MATLAB? Okay, so yeah, so for that the command is inv of X. Inv means inverse. Okay, so this will be only valid only when x has a particular x has a determinant. Okay, or x is non-singular. So suppose you have a matrix like this, 1 2 3 4. Okay, it is a good matrix because its determinant is non-zero, so it will have an inverse. So if you write inv of X, it will show you result. Okay, now suppose you have a matrix, right? 1 0 0 0. If you do inverse of this matrix, it will show you error. Okay, because it will only work some like good matrix. Okay, now MATLAB is very powerful. Okay, suppose you may have a matrix of size of 100 cross 100. When you go to the, I mean in this course as well, when you go to the later weeks, you probably have to deal with this kind of large matrices. Even there, this is a very powerful tool. It will help you. It will give you the inverse in a moment. Okay, for here I am doing it in hand, so this is just for testing the basic thing. Here you can always test with 2 cos 2 or 3 cos 3 matrix, and it will give you correct result. You can always compare with your theory. You can very easily calculate the inverse by hand, and you can compare it. But this is a very powerful thing. For 100 cos 100, 1000 cos 1000 matrix, it will give you specific answers. Okay, now we will do some symbolic. So here the correct option is C and D. C and D are the same thing, inv of X. So just remember, this is you cannot write it like this. This is a wrong answer. This is a wrong result. Okay, inv bracket X. This is the correct answer. Now now again some more new things. So I will go very slowly over here. Now symbolic computation. Now MATLAB is mostly popular for. So did anybody raise hand? Okay. Now oh. now MATLAB is mostly popular for numerical calculation. Okay, so whatever I am doing over here, this 1 2 3 4, or this or this process, catenation process, these things, these are all numerical calculation because I am dealing with number. Okay, but we can also do symbolic computation is MATLAB very easily. Okay, now for that you have to now let's deal with the question. For a symbolic function g, which of the following represents it will be definite integral. Okay, definite integral in MATLAB. So now, in order to get there, let's first just a quick recap of our school level calculus. So what is the meaning of this? Suppose f of x, d of x. Okay, it is indefinite integration. Now when I put some limit to it, suppose x equal to a to x equal to b, f of x dx. This is definite integration. Now just hold it. Okay, just keep it in mind because I am again going to interpret from here to MATLAB code, just like the matrix. So now for this indefinite integration, okay, now let's do part by part. This first sign, this is the integral sign so how we interpret it. This is integration fx with respect to x. Okay, integration of fx dx. In MATLAB we can write it in terms of like this: int of g. Int means this sign integration, g is the corresponding to f of x. So let me write f for consistency. Int of f, that means integration with respect to dx, and we are integrating the function f. Okay, now you have to previously define the independent variable x like this way: mx, and if g and g, here I have written in terms of g. If g is a function of x only, you can just write int of f and it will give you result. Now so this is a valid thing. Now let's go here. int g 1 comma 2 pi. Yes. What is your question?
Yes, sir, I would like to ask, why are we declaring x as SYMSX?
Okay. So so I am erasing this. You already know these things from your school. So just let me just erase it. Just keep in mind the indefinite integration and the definite integration. We are going to use that. Now in MATLAB, in order to do some symbolic calculation. Now what is symbolic calculation? You will understand just in a moment. Okay, so far we have done only numerical calculation. Okay, here all these are number. Now we will deal with symbol. Symbol means, so suppose if you have a function f of x equal to sine x. Okay, now what is df dx? Df dx is equal to cos x, obviously. Now here x is a symbol. We don't have any number here. Okay, I am writing a function f of x is a sin x, and I am differentiating it, and it is giving me result cos x. Here I am treating x as a symbol. Now in MATLAB, to let MATLAB know that x is a symbol, x is a variable, it is not any number. Okay, I have to define this like this: SYMS X means it indicates symbols. Okay, this way I am defining that x is a variable. It is not a number, and then I can proceed with any other information to it. Now when I am writing g equal to x squared plus sin x, it will know that g is also, that as g is a function of x, then it will know that g is also a symbolic variable. Okay, now in order to use this command int of g, you need you must mention that x is a symbolic variable. Okay, otherwise it will not be possible to use int of g, or there are many other symbolic tool which you will get to know as the course progress. So this This is why I am so this is why I am we have to use the we have to mention it to MATLAB that x is a symbol, not any arbitrary number. Okay, if you just write x and dot, if you don't like write this, then it will show you error, because you have to mention something. MATLAB doesn't know anything. You have to mention it. Either it may be something like 0 to 2 to 6. Okay, some vector. This is a vector, like we have already talked about it. Either this is a numerical value or a symbolic value. You have to mention everything to MATLAB. Then only it will be able to work. If you just write x and g equal to x square plus sin x, it will give you error. You cannot do it like in that way in MATLAB. You have to specify that it is a symbolic variable, or it is a number, or it is a or it is a number vector or array. Okay. So yeah, so let's get back to the integration again. So int of g, int of f, int of g indicates that this is the integration. So in MATLAB we write integration as int. Okay. Now, if I want to, this is an indefinite integration. All right. Now, if I want to find a definite integration for some limit, so here this is the correct syntax. int g. This is the lower limit 1, and this is the upper limit 2 star pi. Okay. So you have to write like this. So what in our language, in our common mathematics language, what will be the interpretation? Interpretation will be 1 to 2 pi gx of dx. So this will be the correct interpretation. So the question was, so and this thing, this doesn't make any sense because it just has a lower limit. So you can so suppose you have something like this, x equal to 0, it doesn't have any upper limit, fx dx. So this is not a correct representation of a definite integration. Okay, if you have some limit, upper limit x equal to b, then only it is a definite integration. Okay, so the correct option will be this one, this C. So this will be the correct option for it. Now let's go to the code. So this is the code. Okay, so I have already told that I have to mention everything to MATLAB that x is a symbolic variable. It is not any number. So SYMX equal to x. Okay. So when you write SYMX, it will turn into a purple. So that indicates the MATLAB is now considering it at a symbolic variable. Then I am writing it at g equal to x dot square plus sin x. Now remember this dot. So let me write it here. G equal to x dot square, 2 plus sine of x colon. Now suppose if now if x is any number, so what we do, so here consider this, fx equal to sin x, dx equal to cos x. Now the question is, suppose find the value of df dx at x equal to pi. Okay, now here's I have to put that x equal to pi or x equal to something. Okay, now if x is a single number, just a single number, then we don't have to put this dot here. We can just write g equal to x square plus sine of x. Okay, now suppose you are told that you have to find the value of g at various points, suppose at pi by 2, at pi by 4, and dot dot dot. Okay, and so many values. Then MATLAB will if you do this, okay, x square means it will not be pi square, pi by 2 whole square. MATLAB will not work in this way. Okay, if you want to specify MATLAB that each of the component will be squared, you have to write a dot like this. If you don't write dot, and if x is a scalar or a single value, suppose x equal to pi, then it will work fine. There will be no problem. But if x has multiple values, suppose pi by 2, 5, 6, 7, 8, etc., then MATLAB will give you error if you don't put a dot there. Okay, so just keep it in mind. So if g is x dot square plus sine x, the int of g, so my function is gx equal to, in so I am writing it in our language, okay, I mean in mathematics, not in MATLAB language. Gx equal to x square plus sine x. So what will be the integration of it? It will be x square by 3 minus of cosine x. And you can see that MATLAB in the symbolic computation is giving you exactly the same thing, x cubed by 3 cosine of x. Okay, now so this is indefinite integration. Now I am using definite integration. I am using the limit 0 to 2. Now if I put 0 to 2 over here, so it will be 2 cube by 3 minus cosine of 2 minus 0 minus 1. So finally the result will be 111 by 3 minus cosine of 2. Right? Now you see that MATLAB is giving the same thing. Now there is an interesting thing. As I have mentioned that x is a symbolic variable. Okay, so it is considering g also as a symbolic function. Okay, now you see that it is giving number in terms of it is not giving any numerical value because it is treating everything as a symbol. It is giving you 11 by 3 minus cosine of 2. Now suppose you want to know that what is the numerical value of it, and this is the code for that, VPA. So VPA, suppose I give it, suppose VPA of this same thing, int G02, and it will give you the numerical value, which is 4.08. Now what is VPA doing? VPA is converting this new symbolic value to the numerical value. Okay, and here I have added a 4. If you go to the previous week's lecture, you will see that there is a discussion about this VPA. Here 4 is adding the precision. You are if you don't want to use precision, you are fine. So MATLAB will use some some default precision. You just do VPA of int of g and give it this limit, and it will give you the numerical value. So just remember that VPA, we are using here VPA to convert. We are using here VPA to convert this numerical symbolic value to this numerical value. Okay. Yeah. So now I will go a new topic. So Shoham.
So suppose I want to find integration, definite integration at various points, various values of lower limit and upper limit. How we can find that one?
Well, you can. So far the for loop is not discussed in the course. Okay, so you can always use for loop. So when you learn loop, then you can do it very easily. Just nothing. Just start the loop. Okay. Suppose so I will not discuss about loop today. So when the loop is discussed in the class, then I will talk about it. I will do that problem. So suppose you have some various upper limit. Okay, suppose a equal to 0, 2, 4, 8, and b is the a is the lower limit and b is the upper limit. Suppose 5, 6, 7, and 9. Okay, just start the loop. And each element of this, right, just like the matrix. Okay, so here go to this thing. Here the comment was A11, A12, A1, A3, 21, A22. Okay, that means A of ij. A of ij. Yeah. Now here you have only one index, A of I. And here similarly only B of I. So how you will do it? It will be int g comma A of I, B of I, and the loop is on I. Okay, but that means it will repeat value from I will be first time 1, then it will be 2, then it will 3, then it is 4, and every time you will get this result. It is very simple. When you learn loop, you can do it very easily. I will show that example there when we discuss about the loop.
Okay, sir.
Okay. Now we will discuss. We will go to a new domain, and this will be very useful for you during the course. So just a brief review. I hope you all know what is eigenvector and eigenvalues. Just for a brief recap. So if you met, sorry, suppose you have a matrix A, okay, and there will be some very special vector V, which will agree to this relation. Okay. Now, any arbitrary vector V will not satisfy this. Only some special vector will satisfy this relation. This is called eigenvector, and these are eigenvalues. Now, Matlab has inbuilt command to find this eigenvector and eigenvalue. Okay. Now, first let's deal with the question. I will give you the correct answer. Then I will discuss about it. So the correct one is EIG of A. Okay. Now suppose you have a matrix like this: 1, 0, 2, 3. Okay, it has eigenvalue. It will have eigenvalue 1 and 3. You can check it. Now, if you just like EIG of A, it will give you 1 and 3. These two values. Right. So simple. It will give you two eigenvalues. Now, if you write like this, EIG, if you just like EIGA, and it will give you 1 and 3. Okay, you can, if you have doubt any question at any point, you can Google it anytime. Okay, Google has a very large documents on Matlab, so you will be able to find anything over there. Now, if you write like this, B comma D, or you can write anything, A comma B, M comma N, P comma Q, anything. Okay, just remember that if it has to be some symbol, not any number. You can just write 1 comma 2 equal to something. Just write any variable, any kind of this variable. Okay, just don't write any number like here. EIG of A. Okay, now here this has two eigenvalues. Okay, lambda equal to 1 and 3. That means it will have two eigenvectors, one for lambda equal to 1, another will be for lambda equal to 3. So I am not going to calculate what will be the eigenvector here. Suppose one eigenvector is, I'm not sure if this is the correct eigenvector, is 1 1, and another eigenvector will be suppose 1 minus 1. Okay, I am not sure if these are the correct eigenvector. This is just an example. Now if you write VD equal to EIG of A, yeah, Pramanik.
Sir, I ran that in Matlab,
Huh.
and V comma D equals to EIGA. That gave V equals to 0.7071
Mm-hmm.
1 and minus 0.7071.
Yeah.
So does that mean that V1 is 0 comma 1 0 and 1, and V2 is 0.7071 and minus 0.7071?
Yeah. So when you run this in Matlab, okay, so what is the meaning of V? So these eigenvectors, okay, this will appear in the column. So one will be, this will be 1 1, 1 minus 1, or this is just for the example. Okay, these eigenvectors will appear in the column. This is the first column, this is the second column. Okay, and the D will contain the eigenvalues, but it will appear at the diagonal matrix. That means it will be lambda 1, 0, 0, lambda 2. Okay, so let me just repeat it once again. Just remove this. So you are writing as VD equal to EIG of A. Okay, then V will contain your eigenvectors, and those eigenvectors, each eigenvectors will appear at each column. Okay, so it will, this suppose 1 1, this is the first eigenvector, this is V1, it is appearing at the first column, and another will be maybe suppose 1 0, it is appearing on the second column, V2. Okay, this is first eigenvector, this is second eigenvector, and corresponding eigenvalues, those will appear at D. It will be lambda 1 0, and it will come as a diagonal matrix, and the second one will be lambda 2. So the first one, this is 1 1, is corresponding to this lambda 1, and this 1 0 it is corresponding to lambda 2. Whenever you type in MATLAB, it will give you both eigenvectors and eigenvalue. If you don't write it in this way, only if you write eig of a, it will give you only the eigenvalues, not the eigenvector. Okay, you just go to Google, just search how to find eigenvalues in MATLAB. It will give you the whole documentation. There are various other options which you can deal with it, and you will be able to learn from that. But this is the basic idea. Here I have just shown one example, that 1i minus i1, just to show that this is not only true for the real matrix. Here this is a real matrix, and but here this is a equal to 1i minus i1. Remember that this I is complex I, is here I equal to square root of -1, and MATLAB can work with it very easily. Okay, there is no problem. Just this, the comment for is I, this just small I. Okay, this is MATLAB will understand that this is a complex I. The matrix is 1i minus i1. Here you see that the eigenvalue one eigenvalue here, one eigenvalue is 0, another eigenvalue is 2. They appear at the diagonal, and here this is the first eigenvector v1, and here this is the first eigenvector v2. Now you can try it at home for a 3 cross 3 matrix. Suppose take any matrix 1 2 3 4 5 6 7 8 9. You will see that in case of V, you will get a 3 by 3 matrix. Okay, this one 1 2 3, this will be V1, again 1 2 3, this is V2, again 1 2 3, it will be V3. Similarly, in case of D, you will get a diagonal matrix, lambda 1 0 0 0, lambda 2 0 0 0, lambda 3. You can try, you should try this, okay, to get handy with MATLAB. And just a second. And this is going to be very useful for you, because in course you will always have to deal with this eigenvector and eigenvalues. Okay, just be habituated with it. So let me just 1 second, huh? Yeah, so let's start again. So let me just, so please try it, huh? Okay. Yeah. So now another new comment for MATLAB. So here diff of f. Here f is a symbolic function. Diff will give you the derivative. Okay. Here you can see that SYMS t. Here t is no independent variable. I have to mention that t is a symbolic variable. Otherwise, MATLAB can't work. Like I have mentioned moments ago. F equal to sine of t, and diff of f is giving you the result cosine of t. Okay, fine. Now ez plot f. Ez plot works. You can always find what is the result of the symbolic computation using ez plot. Ez plot f will give you a plot, and if you don't mention any limit. Suppose I have a function sine x. Okay, if I plot it, it can go from 0 to pi. It can grow from 0 to 2 pi. It can go from 0 to 3 pi, anything like that. If I mention to MATLAB, no, that I want to stop at pi, then this thing will not appear. This rest of the thing, MATLAB will show result only up to this point. Okay, only you will get to see only this curve. Okay, now in case this is just similar to ez plot. If you don't mention any limit, I mean where you want to stop, where you want to start, MATLAB will use some default interval and show you the result. You can try this. Now if you want to specify a limit to MATLAB, then this is not the correct syntax. Okay, the correct syntax is ez is written over here. Ez plot f 0 space pi. Okay, you have to remember it, or if you forget, just type find it in Google. So the syntax is ez plot f comma 0. That is the initial position, initial point, and this is pi. Okay, and just just do this, and you will see this kind of result will appear. All right. So this is the plot of sine t. Here the starting point is 0, and this is 3.14 approximately, which is pi. All right.
Sir, difference between EZ plot and normal plot?
Yeah. So normal plot is mostly used for the numerical result. I will show you. It will appear in the later questions. Normal plot is mostly used for the numerical plots. I mean, if you deal with number, not with symbol.
Okay.
Okay. So here another two. Just forget these questions. So how many errors in the MATLAB code? So one thing is that you cannot write like this. Okay, factor if space solve if. MATLAB will not give you anything. Either give a comma or colon or something like that. If you give a space, MATLAB will not understand anything. So this is an error. Now the interesting thing is these two things: factor f and solve f. Here I have given an example. Here again I have mentioned a symbolic variable which is x. Now my function if I have given it some other, you can give any name. Okay, no problem. Which is x dot square. So you can always write x square, but it is a good practice to put a dot because mostly you will deal with vector, not a single variable. So I think it is a good practice. F equal to x dot square minus 1. Now the factor of f. So if I have a function x square minus 1, how can we factorize it? It will be x plus 1, x minus 1. Now factor of f will give you this, right? And solve f double equal to 0. It will give, that means x square minus 1 equal to 0. What is the solution of x square minus 1 equal to 0? It is plus minus 1. Yeah, and MATLAB will give you this result. So these two other comments and their applications. Yes, Shom.
So sometimes I have tried solving equation using MATLAB, but it is showing using Z kind of thing.
Z means
I have solved some equation and it is giving answers in the Z form, and I don't know what is that Z.
Z form means I don't get you.
Using variable Z or constant Z, I don't know what is Z.
Mm, okay. So can you show me something like that? I mean, sorry, I'm not able to understand. Can you
Okay,
share?
I'm trying to figure out
Okay,
and
just, if possible, just share your screen, then I will take a look. Huh?
okay.
Okay, now one small question regarding the function. We will do many things about functions later. Just this is just a small introduction. Now here I have written a function. Okay, now to write a function, please remember the syntax. Let me use some other color because this is important. Let me use red. So suppose you are writing a function. So this is the function u. Okay, that means you want to get the result for u. Okay, equal to some name of the function. Suppose func. Okay, now okay, this is not correct. Let me start from here. Function u, equal to some func, and mention the variable. Suppose a b c dot dot dot. I don't know. Okay, many variables, as many variables as you want, and you want to get a result for u. Okay, then mention u equal to suppose a plus b times c divided by d, something like some function, and then int. Yes, Shom.
Sir, can I share?
You can share. Just wait a bit. Just let me just finish this, and you share, huh?
Yes, sir. Yes, sir.
Okay. So this is the syntax. Okay. So now you have to first save this function to run in the main script. Now if you now if you when you try to save this function, you will find that the name is automatically fixed, and the name will be func.m. And see that mat it has that the I have given the function name func, and the MATLAB is automatically picking this name func.m. This is not a coincidence, because you have to save the function in this name. If you have to save the function script in this name func.m, otherwise MATLAB will not work. Okay. So the first option, name of the file, you please try it. Okay, please try it at MATLAB, then you will be able to understand. So if I will probably I will yes, Pramanik.
Sir, I have wrote what you have written. Function u equals to func comma a comma b comma c and d.
Hmm.
But sir, it is showing that error function
No,
definition
obviously,
not
obviously it will show error. Just a second, huh? Let me just probably I should show this in MATLAB. It will take some time to open the MATLAB. Just wait, huh? MATLAB, yeah, MATLAB online. Just Pramanik, huh? Just give MATLAB is opening, so I will show you. Just let me give you a small example. Just the simplest one. What I did. So function u equal to, here I have named the function as addition. Let's write addition a comma b. Okay. Now write u equal to a plus b colon, then int. Finish it here. Save it. The function name will the MATLAB will save the file as addition.m. Okay. Now go to a new script. Okay. There you just write this comment, addition 2 3. This should be in the new script. Okay. Just write there addition 2 3, and MATLAB will give you result equal to 5. If you, because you are getting the error because MATLAB doesn't know what is u, what is a, and what is b. Obviously it will show error. Okay, like I have told that you have to tell MATLAB everything. So let me just open this thing. I will share my screen in a moment. And okay, so again, so the first option is a true one. Name of the file must match with the first. This is the first function. Okay, first function name in the file. Now, all again, the script file name should be different from the function in the file. So if your function is addition, then the main script file you cannot save at addition.m. MATLAB will show error. MATLAB cannot work in this manner. The end keyword is used to indicate the end of the function. This is true. Valid function name should start from a number, then contain an alphabet and or underscore. This is not true. You have, so a valid function can you try this thing. Okay, so you cannot start it with a number or any underscore. If it has underscore in it, or some numerical values, some plus sign, minus sign, then it will show you error. Okay, I think it is open now. Just a second. Okay, so let me share my screen. Can you share this screen? The function u equal to addition xy, u equal to x plus y int. Hello.
yes, sir, I can see, but I have done the same thing, but it's not
Ah,
taking.
ah, ah. So if you try to save this, it will be saved. Just see that it is saved as addition.m. Okay. Now go to a separate code on the same folder. Just remember that it has to be in the same folder. Otherwise, MATLAB will take something as different path. So here at question 10, right? 9, 10. Yeah. Just see that here I have just written addition 2 comma 3. Now suppose let me change the variable at addition 2 comma suppose 98. Okay, and just run it. So do I have to run the whole code? No, I don't think. Run section. Addition is not found. Oh, sorry, probably. 1 second. It is not in the same path. Why? Add to path. I think now it will work. Yeah, now let's go back to live session one just mix. Where is question 10? Yeah, this is question 10. Now let's try it again. Yeah. Now you see that previously what was the error? Probably you are seeing the same error because you have to add the function on the same path. Okay. So when it is in the same folder, then there will be no problem. In my case, it was in the different folder, so I have to add it to the same path. Now I have written 2,98 and it is giving me this answer 100. Now one interesting question: why it is giving me u equal to 100? Because I haven't added a semicolon over here. If I add a semicolon and run it, it is already added in the same path, and again go to this mix, then probably it will just you will not appear. Then again my run section, where did it go? My computer is a bit slow, so it is taking some time. So if you do in it computer, if it is powerful, then it will just do in some my millisecond. Okay. So okay, right. So in this case, so let me go back to the questions once again. So when it is yeah, so is it done? So when it is done, then I will show you. Then you will see that this u is not appearing. So this u appears because I didn't put a semicolon in my function. If you write this something like this, it will just show answer equal to 100. Okay, so let me just again. Yes, Pramanik. Huh. Now is it? Did it work now?
No, sir. Sir, can I show my screen?
Okay. Okay. So Shoham, you share your screen after this, right? Okay.
Yes, sir, sure.
Okay. Just a second. Let me just record this session and start the new recording. 1 second. Huh? Let me just close this thing. Site. Okay. Just a second. Huh? Okay. Yeah. Yeah. Pramanik. Huh?
Sir, presentation button is not allowing me to present.
Okay. Just a second. Oh, just a second. Huh? Optimize. Yeah. Let me just do this. Go to settings. Media. Hmm. Layout, open function. Can you try now?
Sir, still not showing.
Okay. Can anyone tell me how to do that? I am not able to figure it out.
Sir,
Change
in
the-
the settings format.
Sorry, in the
Sir, in the settings, meeting settings.
in set I am working on settings, audio, video, and resolutions, operation, high definition, integrated channel option.
In the host control, I
Okay.
think you can find out.
Post control. Yeah, you can share now.
Okay, sir, shall I?
Sure, sure, sure.
Okay, sir, can you see my screen?
Just a second.
See, sir, the error is right now there.
Mm, function u equal to func abcd. No, 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 no. See, what you are doing, this is a problem. So don't see, just open a new editor file. Don't write here. Open a new editor file. Okay, yes, go to new. Yeah, now write here some u equal to addition ab. Now write in. Yeah, save it. Go to it. Yeah, you see that the name is already addition.m. Yeah, save it. Now you have now go to the command window. Now write addition 23. That be sure that it is in the same file. Can you see addition dot? Yeah, just yeah, it is there. Addition something bracket inside the bracket. Uh, yeah, yeah. So you get that. Okay. Yeah. Welcome.
Yeah,
So yeah.
thank you, sir.
So Shoham, now you can share.
Yes, sir.
Mm-hmm.
Sir, is my screen visible?
Yes. Okay. So you are getting something like this. Solve x to the power 4 minus x cube plus x square minus 3x plus 1. Change it to some other function. Suppose x to the power 4 minus 1. Hmm. Probably the thing is MATLAB is not, most probably, I'm not sure. I have to check it. Okay, I will try it. Most probably MATLAB is not able to find this value. I mean this the z to the find the roots of these values. Okay. then only then most probably it is showing this kind of thing. I am seeing this for the first time because I generally don't use symbolic toolbox in MATLAB. So it is possible that MATLAB isn't able to find the symbolic value of this function if it exists there. So is there any analytical solution for it? You know?
I found out from a book from this one, the equation.
Okay, so you can factor it. So there is some real solution and imaginary solution.
Yes, yes, yes.
Okay, then most probably MATLAB is not able to find this thing. That's why you are seeing this error.
And
Not
after,
not actually error. So it indicates. I will check it. I will tell you in the next week. Okay. I will
yes, sir.
check it.
Yes,
Yeah,
sir.
but the thing works actually. So the for x to the power 4 minus 1, this is a simpler function, and you are able to get the solutions.
Yes, for some functions I found out the solution, and some functions I found
Mm-hmm.
Uh,
I
this
have
one.
to check that. Most probably MATLAB is not able to find a solution for it. Most probably. I will
I
check it.
think it's a irreducible polynomial. That's why MATLAB not gives the answer.
Sorry.
Irreducible polynomial.
This is
Not
an yeah, it may be possible. So that means it is the it you are saying it is not it can it is not it can be not it is not able to factorize this thing, na. So there no possible factor for this. I will check this. So if x equal to 1,
Actually, sir, from the very basic fundamental of classical algebra, it states that every equation has a solution, so it must have some solution.
it will definitely have some solution, either real or imaginary. The only thing is that
Yes,
it is not always known the how to find a solution. Like you can that theoretically you should be able to any good any integration for a particular for some limit, but numerically it may not be possible.
yes, yes,
Yeah, I will check it. I will check it. Okay.
yes, sir.
Okay, so let's share my screen again. Okay, so now we are done with the MCQ part. Now let's do some numerical steps. Yes, Ankita.
Sir,
Uh,
can you please explain the concept of except the question number 10?
sorry, which question?
Question number 10, last one.
Question number 10. This one.
Yes, sir.
Okay, so the question says that which of the following rules regarding functions in MATLAB are true? Okay, so first, like Pramanik showed shared his screen showed in MATLAB that name of the file must match the function name of in the file. Okay, if you write something like function addition AB, then MATLAB will automatically choose the function name for you, addition.m. If you write something like multiplication.m, subtract.m, MATLAB it will not work. Okay, so this thing is true. Second thing is the script file name should be different from the function file. Obviously, if you name the script file same as the addition.m, then MATLAB will not be able to identify which addition.m it has to choose. Then it will show you error. The third option is the end keyword is used to indicate the end of the function. Obviously, this end indicates the function, so you can stop here. Okay. And the last option that you can try with it in MATLAB, that if you start with a number, suppose u equal to 9ab, MATLAB will show you error. If equal to 9 at the rate ab, MATLAB will show you error. So your name should be some good one, maybe most probably alphabetical name. Okay, you try this in MATLAB, you'll find that this option this is an invalid. This is the invalid case, and other three are true. Okay, now let's go to
Okay, sir.
Now let's go to the question 11. Okay. Again the same thing. So okay, no, this is the new thing. So this is actually works like the same thing like solve. So previously I have used solve x to the power 4 minus 1 equal to 0. Now this is a bit interesting thing. So here now I am doing the numerical thing. So I have covered the so far covered the symbolic part. Then again now I am again going to the numerical part. So here again there is a new function f0. So what f0 does? So first, so here I have defined a function. So in the course in the first week you have learned that you can define a function, small function like this. So f equal to @x x dot to the power 4 minus 1. This is the function. Okay. Now I told Shoham to find the root for it. So he showed that the root are 1, minus 1, 1i and minus 1i. Okay. Now let me just draw this. It will be necessary to understand f0. So here are 4 roots. These two are real root, plus 1, minus 1. These two are the imaginary root, plus 1, minus 1i and plus 1i. Okay. Now when you are using f0, you have to, so f0, if you do here, you don't have to specify double equal to 0 like the solve. This is in the syntax. You will understand, you will remember it as we go along. So here f comma 1.5 pi 1.5 I, this is the initial guess I am taking. Now you have to provide some initial guess, 0, 1, 2, 1.5 by 2.5 by anything. Now one interesting thing about f0, that it will only give you a single root. It has, we know that from theoretical solution that it will have 4 roots, but here it will give you only a single root. Okay. Now here my initial guess was at plus 1.5i. Okay, suppose this is the point 1.5i. Now from intuition, can you tell me which one of this 4 root it will take? Which one of these 4 roots? I am taking, so what I have told, that f0 will give you only a single root at a time. Okay. Now I have to specify an initial guess. Now here I have provided at 1.5i. So obviously it will go to this value because this is the nearest. Okay. Now if I take the initial guess as minus 1.5i or minus 2.5i or minus 0.5i, suppose I'm taking the initial guess here, some point, it will go to this value. Okay. Now if I take some, now how can I reach this point? Now when I am imaginary axis, it will not bother to go to the real axis. Okay. Now to find a solution on the real axis, I can take a root there. Suppose that initial guess at plus 2, then it will go to plus 1. It will not go to minus 1. You can try it. It will not go to minus 1 because it will take so much iteration, so much computation time. Going here to there is much easier. If I take a root, initial case as minus 3, it will go to this point. Okay. Now you can play with it. You can take some larger function. Suppose x to the power 8 minus 1. Okay. And take various initial points. Anyway, take various initial points over the domain. Later I will show you that from this plot using f0 we can generate some beautiful plots. When we yes, Pramani, just a second. When we will learn how to use the for loop and for loop, while loop, those things, then I will show that using this thing we can generate some beautiful plots. Okay. So here so far, so here, so only, so the take home message is only one root at a time. So and what root you will get will depend on your initial guess. Okay. You can take some initial guess over here and it will go to some point over here that I haven't checked so far, but you can play with it. Yes, Pramanik. Hello.
Yes, sir. Sir, if I give f comma 1.5, it returns 1. But sir, if I give the point f comma 0, then why am I getting only minus 1? Because 0 is symmetrically placed between all of them.
So it can vary. So if you so try with 0.01.
Yes, sir. F comma 0.01 is also giving minus 1.
Minus 1. Okay. So that so it means that, this is basically mostly the logical idea. But MATLAB. So what is inherently MATLAB doing inside F0, that we don't know. Okay. So so suppose if you take some point over here, some point over here, which is near to this, so Matlab will find some root, and which suppose in that case most probably going to -1 is taking less computation time. Okay, compare to +1. So if you can try at various points. Suppose take some 1 plus to 1 plus 2y, suppose 0 minus 0.5y, some plane. So I have taken only points at the only real axis and the imaginary axis. You can always take guess at any other point, this because this is a whole xy domain, whole real axis and imaginary axis. You have infinite number of initial guesses. Just play with it and you will be able to find. It is not always trivial. You are true, fine, you are right. But if you take some initial guess at 3 or -5, it is most unlikely that from -5 it will go to +1. Okay. So what is happening inside MATLAB that we really don't know. So in order to do that, you have to understand that how the code of F0, this is just a command, right? But it is actually written in some other language, in C. So you have to understand that what is written in C language in order to understand what is actually happening in F0. So this is just an intuition that if you on the imaginary axis you will get roots on the imaginary axis, on real axis you will get root on the real axis. But yeah, this is non-intuitive. When I have mentioned that I will show a plot later when we learn in the for loop thing, then you will see that this is the most unintuitive thing. What you will get the which root. Suppose from it is most probably possible that here you are at +100 but you are going at -1. It is possible. Okay, it depends on MATLAB and we can generate some beautiful plot based on that. Yes.
Sir, in this graph, if I want to plot somewhere not on the axis, so
Hmm.
what will be the command for F0?
Same thing. Some if plus so how to write the initial case, then it
Yes,
will
sir.
be
If it
a,
is
a,
not on the axis,
a plus bi, simple,
sir,
not ib, bi,
sir, but it is not taking. I'm writing F0 f comma 4 plus 8i. It is returning error using F0.
f0 4 comma f0 f comma 4 plus 8, it is showing you error.
Yes, sir.
F0 f comma 4 plus 8 I, it is showing you error. Hmm. Show me your screen.
Yes, sir.
Is it possible to increase the size?
Sir, I don't know how to increase the size. I have no idea regarding that. Sir, I
Uh,
can.
Once again, go to preference. Yeah, you see there is a font size in the left. Go to left. You will find a font. Yeah, make some bigger font. 20, 25, anything. Yeah. Yes. Huh. If x equal to x dot to the power 4 1, function value at starting. Error using F0. Show me the complete error. Function value at starting guess must be finite and real. Oh, then it is a problem. Actually, this is not an error. If you interpret that, so x to the power 4 minus 1, so that means 4 plus 8i minus whole to the power 4 minus 1. So this thing is actually an imaginary number. That's why you are getting an error. Okay. Yeah. Okay. So I will tell you in the next week. Okay. Just
Okay, sir.
I will keep it in mind and tell you in the next week.
Okay, sir.
Giving error. Okay. Okay. And mm, yeah, and another root. So let me just mark this thing. This. Okay. Okay. So let's go back to the thing again. Uh, so the next thing is f equals x square sine x plus y square cos y, and I have to find f x y. That means, so del square f del x del y, I have to find that. Okay, so already we have learned how to deal with this. So here I have two symbol, one is x, another is y. Sy mx s x space y. Oh, sorry. Okay, so I have to find f equal to x square sin x plus y square cos y. I have to find f x y, which means del square f del x del y at point at x equal to pi and y equal to pi by 2. Okay. Now here this is sy mx x space y. This is the, so I have now two symbols. So this is the syntax for this. Give a space between x and y, and it will take it. So I am writing the function f equal to x dot square dot star sine y dot star in the, so or it is, so I have told that it's a good practice to put dot plus y dot square dot star cos x. Oh, I have written it down anyway. So to cos x. So maybe it is a cos x. Now f of xy, that means del square f del x del y. So first there will be a differential with respect to x, that I have written it dif f comma x, and I am differentiating the whole thing with respect to y. So the, just to interpret, suppose consider g equal to del f del x, and then I am doing del g del y. Suppose this diff f x is g, and I am doing diff g of y. All right. If you and you will find the result at fxy equal to 2x cos y minus 2y sin x. Okay. Now you have to find the value at pi and pi by 2. Now in the code, now this is the command for that. Subs means substitute. In Matlab we write it at subs. Okay. So fxy, this is the syntax, comma xy, comma pi by 2. Simple. In space of x, I will put pi. In space of y, I am putting pi up to pi by 2. Now, if you have a single variable, then it is very easy. If x, comma pi. But here you have multiple variables, so you have to put it inside third bracket, and this is the syntax for that, and you will get the final answer 0. All right. I hope this is clear. Now again the same thing I am doing, just same thing. So we have already learned how to integrate. F equal to 2x sin x plus cos x, integrate from 0 to pi. So f equal to x sin x plus cos x, you can always put dot star this like that, and int f 0 comma pi, and it will give you result. And remember that we don't, you don't have to put dot plus or dot minus. Okay, because it means the same thing. If you have a vector, if you have a row vector, suppose 1 comma 2 comma 3 comma 4, and another vector 1 2 5 comma 4. Okay, and if you do a minus b, then by definition it will do term by term subtraction. Okay, so then it will not be a problem. So you don't have to put dot plus or dot minus, but put dot star or dot divided by this thing. Okay, now a problem from school level thermodynamics. This is use the thing PV equal to constant. Okay, the pressure and volume for ideal gas, pressure and volume equal to constant for real temperature. Now we are going to prove it using plot. Now I have told earlier that I will do many problems using this plot. So now this is the first one for that. Okay, let me just save my recording. Okay. So, and I have provided some values. At p equal to 1, v equal to 100, p equal to 2, v equal to 53, p equal to 3, v equal to 33, and dot 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 dot. Okay. So you can see very easily that I have taken such a way that pv equal to 100. I shared a jam file with the meeting. What is this? Yeah, Kuldeep, do you want to share something? Hello? Okay. Okay. So so let us continue. So you can see that I have taken it such a manner that PV equal to 100 all the time. But we want to verify it using plot. So how to do that? So here I have given, so I have to write all the P values 1, 2, 3, 4, 5, 6, 8, 10, 20. I have written all the V values. Now I am using figure. Okay. Now just the basic thing. This is PV equal to constant. That means log of P plus log of V equal to log of K. Now if I treat this at x-axis and this is as y, I will get a plot like this with a slope of -1. So that means y equals, and it will be, sorry, log of K. Y equal to log of K minus x. So this will be slope of 1, and the intercept value, this is my log of K. So from here I can find the value of log of K, and log of K, suppose some value, suppose b, then k will be equal to e to the power 10 to the power b or e to the power b. Okay. Now plot log p log v. Now remember, when you write log in Matlab, it automatically indicates log base e. Okay. If you want to write log base, if you want to base 10, they like log 10. Okay, not only log. But we will mostly work with log base e. This log means log base e. Okay. Now I have use the plot log p log v, and I am getting this curve straight line as expected. And this, you can verify the slope is -1, and it is intercepting at a point 4.6. Now when you move your cursor, over this plot, it will show you, automatically show you all the points. Okay, you will find that it is close to 4.6. That means your log k base e is 4.6. That means your k is e to the power 4.6. So this is the constant. Okay. Now is now a problem from kinematics, from class from the school level again. So now displacement of a particle is given at xt equal to ut plus half of at square. We all know that. Now plot trajectories for u comma a. Here a is the acceleration. So based on u and here I have two unknowns, u and a. I have to plot trajectories based on ua. So in the first case, u is 3, a is 0. That means this is uniform velocity. 3 comma 1, that means initial velocity is 3 and it is accelerating. This is +1, and this one 3 comma -1, and it is decelerating. And compare ti equal to 0, tf equal to 5. That means my initial time is 0 and t final is 5. So I have to compare these three conditions for this given time. Okay, and we can do this very easily. Now I am introducing a new thing, lean space. Okay, lean space. So this indicates that its starting point is 0, ending point is 1, but an intermediate step is 100. Okay, intermediate space, that is lean space means linear space. Okay, so the intermediate steps will be 100. So this is t equals lean space 0, 5, 100. This is the comment for that. So in all cases my velocity is 3, so I am writing u equal to 3. A is different in 3 cases, so I am writing a equals 0, 1 and -1. Okay, in first case it is 0, in second case it is 1, and in the third case it is -1. Now here, so here I have 3 trajectories. So here I am writing on based on 3 conditions. x1 is ut times t plus 0.5 a1 times t dot square. So here I have written in separately because we don't know for loop so far. When we use for loop, then we can do it very easily. Okay, but here I have written it separately so that you can easily understand. X2 is u comma star t plus 0.5 star a2 times t dot square. Remember, here I am using dot square because t is not a single value. T is a vector. Here initial this is ti, as I have mentioned, ti equal to 0, and this is tf. Okay, and similarly I have written x3. Now I have to plot x1, x2 and x3. So again figure. When you are writing figure, it will give you a new figure. Alright, new figure. Now plot t x1 comma k star. Now so there are some inbuilt color in Matlab like K, M, G, R, B, Y. Okay, here K means black, M is magenta, G is green, R is red, B is blue, Y is yellow, and C is cyan. Okay, these are some inbuilt color in Matlab. Just Google it, you will be able to find. And here K star. K star means just see here star. You see that here I have plotted, this is a black line, and here all the markers, all the points, it has put a star here. It indicates K star. Hold on means the new plot. Here I am plotting a new thing. New plot will appear at the same plot. Okay, if you don't put hold on, then this plot will erase. Only this plot will appear. So you have to put hold on if you want to do various plot on the same figure. Okay, then plot t comma x2 r dash dash. Okay, r dash dash means see this dash 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 dash. Okay, so this is the meaning of dash dash. Okay, so these are basically some markers if you want to separate different images. And again I have written something line width. Line width means the width of the line will be 4. Okay, so and see that here this is a simple plot t comma x3. Here this is the simple straight line, and here you can see the effect of line width. Here this is the basic, this is the default line width. And here line width equal to 4. So you can see the difference. Okay, this way you can modify the pictures. Okay, and another thing is left, legend. So here x level t, y level x, it indicates the x level t, y level x. Okay, if you wish you can provide a title. You can write something like this, title some blah blah here. Remember that it will come under quotation. Okay, whenever you're writing a string like this, it will come under quotation. And legend. Okay, one is a equal to 0 comma a equal to 1. Each of them has appeared inside the quotation, and here you can see the here. This is for a equal to 0, this red, this is for a equal to 1, and here this thing, this yellow line, this is for a equal to -1. All right, so I hope this is clear. Please try this. Okay, otherwise you will forget. I will this PDF copy, but not this rough copy. The fresh copy will be shared with you. Please try it in Matlab. Now again, find the velocities at TF, but at the final time for three different days for three different accelerations in question 15. That means I have to calculate a velocity. I am given this profile, and I have to calculate the final velocity for these three cases. Okay, so I am using the symbolic thing xt equals u times tt plus 0.5 times a times tt dot square. Okay, I haven't put in a semicolon over here, so it has something has appeared over here. Okay, now remember, already my u and a are specified. I have specified in this code. Okay, u is 3 and a is 0, 1, -1. All right, now ut equal to diff xt comma tt. Okay, so previously I have told that this is the syntax diff f, or here I am differentiating xt with respect, or you can mention the, or it is up to you, because here tt is only the symbolic variable. Here I have mentioned it, diff xt comma tt, but you can always write it like diff of xt. MATLAB will automatically assume tt as the independent variable and work well here. So ut equal to diff xt comma tt. So here you will see the three different velocities. One is 3 constant, another is tt plus 3, another is 3 minus tt. So here figure t plot equal to linspace 0 500, and then substitute ut tt t plot. Okay, so I am substituting the, so I haven't put in a semicolon, so various values are appeared over here. So don't consider this. So what I have told, that if I want to, so here in place of tt, I am substituting a vector. Here I am substituting a vector t plot. Okay, so again here, I will do the plotting. So here this is a symbolic thing. So I am using ez plot. ut1 means, ut1 means my first thing, the corresponding to this ut1, and the limit is 0 to 5. Hold on, that means hold on, that means I want to do the plot on the same thing, on the same figure. Ez plot ut2 0 and 5. ut2 is this one, tt plus 3, but remember I have already substituted it with the numerical values. ut2 0 5, and again ez plot ut3 0 5, and hold off means I was plotting on the same figure. Now I do not want to plot on the same figure. And the new, and if I do the new plot, if I want to plot something else after hold up, it will appear on the new figure. So again, x label t, y label u, title velocity for plot, and here this is the syntax was given axis 0 5 minus 10 10. So it will interpret as this is the x0, this is the xf, that means initial, and x final, this is y0 and yf, and here this is the plot. So this is, so I haven't I forgot to put legend here. You can always put the legend here. This is for a equal to minus 3. As expected, the velocity will decrease. Here this is for a equal to 0, the velocity is constant, and here this is accelerating, and here it is for a equal to 3. Okay, just go through it. This is a little bit complicated, but I think so far what we have done, you will be able, if you go through the whole note or whole lecture, whole lecture, you will be able to understand. I have only used all the things that I have told so far, but this is a little bit a larger problem. Okay, so here this is the thing. So I am previously I've substituted in space of symbolic variable a scalar. Now I am substituting a vector. Okay, because you always have to work with this vector. So here, remember this thing, I am in space of tt, I am substituting t plot, I will get some number, and here I am using ez plot to plot those results. Okay, now let's go to the second problem. These are all some plotting exercises. Okay, so now plot f equal to sin x, g equal to cos x on the same plot. We already know how can we do that. On the same plot, specify title, axis labels, and legends. Okay, so here I am using x equal to 0 to 0.1 to 2 pi. So in the probably in the third question, so 1 2 3 2 9 something was there like that. This is the same thing, 0 to 0.1 to 2 comma pi. That means 0 0.1 0.2 up to 2 pi. It will consider this value. Or I can use linspace 0 2 star pi comma some number. Okay, suppose 100. That means 100 spacing will be there. Okay, between 0 and 2 pi. You can use anything. All right. Now suppose yes.
Sir, in the previous one, question number 16, you used a command tplot equals to linspace and something. Can you please explain that one more time?
Mhm. Sure. So what is the use of linspace? Okay. So I can write, so I am explaining it here. So here I am written or x equal to linspace 0 comma 2 pi h. H is not step size. H will be number of steps. Sorry. So I can write it 0 colon 0.1 colon 2 star pi. We already know what is the interpretation in normal language. All right. You, we already know this. Now if I write linspace a comma b comma 100 maybe. So that means MATLAB will assume, so this is a normal x one dimensional number line. This is A, this is B, and MATLAB will divide it in 100 equal spaces and take all these numbers. Suppose this is A plus 0.1, suppose A plus 0.2, A plus 0.3, dot, 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 it will proceed like this. Is it clear now?
Uh, yes, sir. Sir, but when we are using tplot equals to linspace that command, will it be storing that in the array of tplot?
Yeah, yes, yes. If you provide it a name, any name, some variable name, t plot, x, y, z, etc., anything, it will store in it will store in that name because when you are operating, okay, you cannot you it is I mean it is a dumb idea to use or always use this kind of thing. Suppose you have to uh, add two vectors, okay. So one vector, suppose you want to add, suppose you have some data file 0, 0.1, 0.2, 0.3 up to 100, and here it is 0, 0, 0.5, 1.0, 1.5, dot 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 up to suppose 1000, okay, because up to 1000, because both vector has to be the same size, otherwise you can do addition, okay. Now you can provide a name to it, x equal to, and this will provide a y equal to. If you add simply just x plus y, it will give you the result. Or you can do another thing, you can just write 0, you can write 0 to 0.1 to 100 plus 0 to 0.5 to 1000. Okay, but we define the variable name to simplify our calculation, right? In algebra, we always specify some variable because it simplifies our calculation. Same thing appear for MATLAB. If you just write here instead of x is this thing, if you write x equal to linspace 0 comma 2 star pi comma 100, it will store the value in x. Okay. Okay. So I think this is clear so far. Okay, now I have to plot sine x and cosine of x. Okay, now here this is f equal to sine of x and g equal to sine of x. Okay. Now I am defining figure. Figure means a new figure will appear. Now I am doing plot x comma sine of x. Okay, then hold on. This is the same thing I have already told, but just for practice. Then hold on. That means the new plot will appear on the same figure. Hold on, plot x comma cos of x. Then x label x, that means it will define the label of x on the x-axis. This is x, and y label is y. Okay, if you see the plot, this is x and this is y. And title, again it will appear in the string inside the quote, sin x and cos x plot, legend sin x comma cosine x, and axis 0, 2 pi, minus 1, 1, and what I have told that this command exists. Just remember this, how to write this command. Okay, it will help you. Okay, so this is the x0, that means the x initial. This is 2 pi x final. This is y0, that means the y initial, and this is the y final. I am specifying the limit, and here is the plot. You can see this is -1, this is +1, this is 0, and this is 2 pi. This is approximately 6.28 pi. And the title has appeared, sine x and cos x plot. This is the y level, this is the x level, and these are the legends. Okay, here I have not specified any color. Okay, I have just written plot x comma sine x and plot x comma cos x, and here MATLAB is picking some default colors. Okay, and this is one default color, another is default color. I am not specifying anything. Now modify the plot in 17, change color and markers, etc., etc. Now you have to now you have to do some art on the plot. So again the same thing. I'm not going over the same. One second, just okay. So now I will not go over the same thing. Okay, but here, now see here I have specified a color and dash dash indicate the marker. Okay, hold on, a same thing. Here I have specified the color in specified a color over here, that is K. K means black, and I have not specified any marker. That means it will be black solid line. R dash dash means red dashed line. Yeah, Shoham.
So can we use hash code for this one?
Hash code means?
Color
Uh,
hash codes?
Most probably no. I haven't tried that. Just try it. There are some inbuilt markers in MATLAB. So far I have used dash dash star. Okay, then D means diamond. O means circle. I haven't used hash so far. But try it. I don't know if it is possible or not. If it is
So
not
actually,
possible,
hash codes for colors.
hash codes for color means I do not understand. Oh, that
Uh,
means okay. So you want to specify the values, RGB values.
yes, yes.
You can do that. You can do that. So in the next, so in that case, what you have to do. So if I remember correctly, so something in, so suppose plot X. So for the others, so each of this color come with some value. Okay, this is called RGB data. So if you search in Google, you will find it. For K, it is most probably 000. Most probably, I'm not sure. Okay. So in case of that, then mention color and then provide the value. Suppose 1.5. No, it will be below 1.5. So 0.7, 0.1, 0.2 something. This is most probably the syntax, just check it. But you can always use RGB value. MATLAB can work with that. Okay. So here I have modified. So here I have modified the plot. Okay, and this is the result. So here this sin x appear in the dashed line and cos x appear at the black solid line. Here these are the legend, this is the title, this is the y level, this is the x level, this is the x starting point, this is the x ending point, and this is the y0, and this is the yf. Okay. Okay, then again modify this picture. So this is not beautiful enough, so I want to visualize this clear. I will visualize this better. So
Sir, how we define the axis? 0, 2 pi, minus 1, 1.
uh, this one, define axis, change it to anything 0 to 4 pi. Okay, minus 1, minus 2 to plus 2, anything, it will work, no problem. You can specify limit as you wish.
Sir, I'm saying that on x-axis it's 0 to 2 pi. Means
On
then
x-axis, so You are talking about this, right? This thing, right? You are talking about this.
Yes, sir.
Huh.
Means
So
I'm talking how I write
how you write
for
them is
A,
so
means for
yeah, so
axis and y axis.
yeah, so yeah, so this is the syntax for both of the axes.
Means 0 to 2 pi a on the step length minus on 1.
It will it may be possible that you can mention, yeah, I think you can mention the step size. Okay, suppose you wanted 0 at pi by 2, pi 3 pi by 2, 2 pi. I think you can do that. Just Google it. Matlab allows every kind of plotting operation. Okay, it has a very strong plotting toolbox. You can do all those things. Okay, yeah, but if you want to give some basic default step size, okay, just this is the comment. First bracket, then inside that use second bracket. This will indicate the starting x point, that means the x initial. This is the x final. Here I am using 2 pi. You can use anything you like, or the starting point doesn't necessarily have to be 0, it can be anything. Then the starting y and the closing y, ending y. Okay, minus
Okay,
1
sir.
to plus 1. Okay.
Okay, sir.
Now we want to make this plot even more fancy. Okay, so same thing. This thing are all the same. Here I have mentioned G star. This is the new thing. G means green, and G star means green star. So the marker will be star. And yeah, this is also a new thing. Marker size. It will. So previously we have learned a line width, and now this is marker size. Okay, marker size 6. Hold on, x cos x, m, m means magenta, and here line width is 4. Okay, these things are the same. I am not going over, I am not repeating this. Yeah, and now see the plot. Okay, yes,
Sir,
yes,
what is the difference between line width and marker size?
yeah. So when you have a line, okay, just a line, then line width will work. Okay, but if you have marker, this kind of thing, there is no line. For that, you have to use marker size. Okay, when there is a line, because on line you cannot, because line is not a marker, line is just a solid line, there is no marker. Okay, marker, you can just see this plot. Okay, this is not a constant continuous line, this is just some dot, star 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 star. If you use line with Matlab will show you error, because this is not a line, this is just this is just some collection of stars, these are not connected. Okay, that's why I have to use marker size. But here there are no marker in the on this plot, there are no markers. Okay, this is just a solid line, so here you have to use line width. And remember one thing, so I forgot to mention, see this very carefully. Marker start with a capital M, then A R K E are small. Again size appear with a large S. Similarly for the line width, line start with a large L, line, then width WYDTH, width start with a large W. Okay, yeah. So this is the thing. Now the last question. Yeah. So this is another mathematics exercise, and I will end it by showing again EZ plot. So what is the series we all know what is the series expansion of e to the power x, or exponential of x. That is 1 plus x square by 2 plus x cube by factorial 3, that means 6, plus x to the power 4 by 24 plus dot 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 dot. Okay, now when x is small, sorry, it will be 1 plus x, not x square. Now x tends to 0, then e to the power x equal to 1. We all know that. Now for small value of x, I can approximate e to the power x as 1 plus x. for a slightly larger x, because why? Because suppose x equal to your 0.001. If you square it, so it is already 10 to the power minus 3. It will be 10 to the power minus 6. Cube it will be 10 to the power minus 9, 10 to the power minus 12. So it is almost negligible. Okay. For a slightly larger x, suppose x equal to 1, then you have to consider this thing. So not necessarily 1, suppose 0.8, then you have to consider this term, then probably this term. Okay, but other terms will be 0. So this is an exercise to check that thing for what will be the upper limit of x for which this approximation satisfy. Okay, so here I am defining a symbolic variable. You can do it numerically. Okay, you are free to do that, but here I have shown a symbol. I have done a symbolic computation. So here I am mentioning a symbolic variable syms t. Now here f1 equal to 1 plus t, f2 equal to 1 plus t square by 2. Okay, so here I haven't mentioned t dot square dot by 2. I haven't done that because I will treat t as a scalar, not a vector. Then f3 is 1 plus t square by 2 plus t cube by 6. Okay, so here these are the three symbolic functions, f1, f2 and f3. These three are the three different symbolic functions. Now again figure. Figure means a new figure. Now EZ plot exp of t 0, 1, 0, 1, 2. So I am plot. So first I am doing the I am plotting the original plot exp of t. So probably I have not mentioned exp. Exp of t in Matlab, it will take the exponential value. Okay, exp. This is the comment for that. Like sine, like cosine, this is another exp. Probably I haven't mentioned it during this lecture. So this is EZ plot exp of t and limit is 0 to 1.2. Hold on, that means all the new images will appear on the same figure. EZ plot f1 0 1.2. So okay, so 0 1.2 means it will go from 0, the initial point is 0 and the ending point is 1.2. So here here f1 is 1 plus t and it will plot from 0 to 1.2. f2 is 1 plus t square by 2. It will plot from 0 to 1.2, and again f3 it will plot from 0 to 1.2. Here there are four different plots, so four different legend. Exp of t, f1, f2, f3. Title I am giving exp of t because I am comparing it with it. So you can add x level, y level. I haven't added that because we already know how to use that thing. You can do that. Okay. Yeah. So you can see that this is the comparison. So for this, so you can see, so you can modify this result, increase this plot size, increase this using line width and those things. I don't know if those things work for EZ plot or not. Just check that. Or we can always use normal plot and do the same thing. You can actually try it at your home. Just I have done it using EZ plot. You can always use normal plot, or you can do simply the new. So in that case, you have to consider x t as some vector. It will vary. Suppose t equal to some linspace 0, 1.2, 100. Then mention those function f1 equal to @t 1 plus t, f2 equal to @t 1 plus t. Here as it is a vector, you have to write t dot square by 2. Okay, similarly f3, f4 and exponential of t, and you can do the same thing. Okay, it is up to you. You can try that at home. So here I am plotting it with exponential t and corresponding f1, f2 and f3. You can see that for a small range, the f1 is agreeing with that f1 equal to 1 plus t. Okay, for a very small range. If you in plot, if you move your cursor over Matlab, you will be able to see the point. Okay, you will be able to see the point. See, this is suppose it probably at 0.17. Probably here x is 0.17. Okay, most probably. Then up to some point, up to probably here, f2 is agreeing with exponential of t. Again, if you move your cursor over this plot, you will able to see this point. This is probably at 0.38. Then up to this point, f3 is working fine. This is maybe at 0.62, and after that exponential t is exponentially deviating from f3 as well. Okay, so this is a good exercise. You can always try that and play with it. So these are all the 20 questions that I have planned to show you. So if you have any, yes, Sean.
Sir, how we can write anything in factorial like 8 factorial in MATLAB?
Mm, okay, just let me just Google it. I also forgot, and I will tell you. Most probably factorial. Most probably the name is factorial. Factorial MATLAB. Factorial. Just use factorial of 2, factorial of 3. Yes, Pramanik.
Sir, suppose I'm doing some work today, so I'll be writing something in the command window, but I don't want it to disappear the next day or next time when I open my computer. So, will it be saved automatically, or do I need to save that?
I don't think it is possible. You have to write in the script file and save it. I don't think it is possible in the command window. Most probably no.
Okay, so I have to save it in some other text file.
No. I mean, just write just what I have told you, what you showed back there. Just click on the new. What you are doing in the command window, write there and save it. It will be saved.
Okay, sir. Okay, and sir, I had a few questions I'll ask you after after you have completed.
I have completed. You can ask.
Okay, sir. The questions are, sir, I have also enrolled for quantum field theory, part two, that is currently going on from IIT, I think Hyderabad. So both the MATLAB test and the quantum field test are on 30th of April, as
Uh,
far as I think.
okay, so you can deal with this kind of thing with the NPTEL team. You contact them. Okay. I
Um,
don't know this kind of details. I will just take the live sessions for this subject. I don't know those. I don't know about those things. You ask them. They
okay,
will respond. Huh?
Okay, so sir, another question is that, sir, I have enrolled just 2 days ago in this course, so I have not been able to watch all of the videos, but I have seen that there are two assignments whose deadline are on 8th of February. So, are those the final deadlines, or will it be extended forward?
Also, I don't know about these things. I am just here to take the live session, but I have also done some courses in this NPTEL. Most probably, those are the final deadline. Most probably, they will not change it.
Okay, sir. Thank you, sir.
But verify this, huh? And also those of you who don't have access to MATLAB, also write it to them. They will respond. Yes, sure.
So in MATLAB, can we, in the output format, can we use interactive something? Like I want to plot y is equals to a sin x, and I want to define a for various values in the out.
Same loop, same for loop. Yeah, when we will do for loop, we will do many such like that. So if y equal to a sin x, suppose a equal to 1, 2, 3, dot 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 100, and you want to plot it on the same plot and see, right?
Uh, like sir, in Desmos and GeoGebra, we found.
It's the same thing. MATLAB is much more powerful than those. Okay, you can do anything in MATLAB. When we do just for loop, you will be able to see how we do that. This is very easy. This is just 3-line code. Just you need to get familiar with for loop, and this is a very easy thing. You can do everything in MATLAB. This is a very powerful.
Okay, sir.
Okay, so thank you everyone. So let me finish here, and I will continue it from the next week. Yeah, yeah. Somebody raised a question.
Sir, could you please send us this PDF? this one.
This will be sent by the MATLAB, the NPTEL team. This will be sent. Yes.
Sir, it will be very beneficial for us if we could get the live sessions like we are getting today, because
Yes, that will be shared as well. But you want to see the record once again. If you want, it will be shared. No problem.
no, sir, I'm not saying that. I have recorded in OBS this whole session so that I can reread it afterwards.
Uh,
I don't need the recording, but sir, I'm saying that in the Swam app, I'm seeing the recorded videos which are of 2020, as far as I know.
mm,
But sir, like the session that you are taking today,
mm.
which is an interactive session, because I was doing last day, but a lot of problem arise now. As you were doing live, so a lot of problems has been solved instantaneously, and that was increasingly helpful for me and grew my interest in on the topic also. So
Yeah.
will we be getting such live sessions through Meet?
Yeah, so these like this, there is another person in this course, so whose live session will be at probably at Tuesday. Okay, so I will take the live sessions on Sunday, and he will take his live session on Tuesday. So those two live sessions he will get in a week.
Oh, thank you, sir.
Okay, okay, okay. So goodbye, everyone. Thanks. Okay, let's meet next week.
Thank you, sir.
Thanks.